Sci 30s, welcome to Unit D, Topic 2.2, the many forms of solar energy. This is it. This is the last topic we're going to deal with to finish up the course. So I'm very excited to kind of wrap up the course and finish up Unit D for you here today. Um, as you may kind of get from the title, we're going to be dealing with the various forms of solar energy that can be used, and these are generally speaking, all considered to be renewable forms of energy that all tie back. They may have several layers of, um, separation from the direct solar energy that initially created these forms of energy, but they all originally had their energy creational form started with solar energy. We talked about it earlier in the unit as well when I talked about fossil fuels and combustion reactions with burning, say, wood, coal, oil, petroleum, natural gas. These also are technically all related back to solar energy because, again, you would have had photosynthesis that would have created all of these products that eventually either get cut down like trees or get fossilized like coal or petroleum or natural gas. But the difference with those ones is they are, other than wood, the burning of wood, they are all considered to be non-renewable forms of energy, and all of them kind of create larger than probably wanted amounts of greenhouse gas emissions and other potential toxic substances like polycyclic aromatic hydrocarbons or PAHs that we discussed back earlier in the course. So these forms of energy here, although not 100% perfect by any means, are all examples of what we call renewable resources that have maybe less of an impact on the ecosystem or on the planet as a whole. So we'll start off with the very simple one, which is passive solar energy. Most homes out there have some form of passive solar energy built into them. They have windows. If they're facing toward the sun, and especially in the winter, you may be very familiar with this. If you've got a south-facing window in the winter, that window can really heat up your space if it's a sunny day, even though it's cold outside. That sun tends to radiate through the window and creates that radiant heat energy inside your house, and that actually can help to reduce heating costs in a home if you've got a window that is facing the sun during some of the colder winter days, provided that window is properly sealed, when it's installed. As well, you can also prevent overheating of a home in the summer. Certain home designs will help to reduce the quantity of solar radiation directly entering the home to keep it cooler. So there are other methods that can be used to then, if that window was facing south in the middle of the summer, that would become a problem, heating up the home a little bit too much, maybe forcing someone to use air conditioning, which we don't want to do. So the home designs can also be, if you're in an area that has a hotter temperature, they're going to have different strategies. They're not going to have a bunch of windows facing south. They're going to kind of get their windows facing away from the sun and prevent that radiant solar energy from coming in. Like say if you're living in a place, let's say like Las Vegas, and was fortunate enough to live there for a few years, and we had a window that faced north, and we were always very happy that our window faced away from the sun, so you weren't getting the sun beating down on your window when it was 42 degrees outside in the summer. So again, simple designs like that can help reduce heating costs or air conditioning costs in a home or a dwelling by just simply using that passive form of solar energy to either help heat or help to try to keep your house cool, by proper home design. When we think of solar energy, though, we think more of what we call solar heat collectors or solar panels. That tends to be one that we hear more about. And there are actually two types of solar panels out there. There are what are called solar heat collectors, as I just mentioned. These are panels that would be put on the roof of a house or a business, and they are not designed to create electricity. They simply take the radiant solar energy that's coming down into the panels and converting that into thermal energy, which can then be carried by a fluid pumped through the collector. So it's sort of almost like if you have in-floor heating in your home, this would be a form of that where the fluid would then move into the house and then warm the house up because it's being warmed up from these solar heat collectors on the outside of the dwelling. It can be used to heat a home, but it can also be used to heat water as well. So if you don't want to have, let's say, a traditional natural gas powered water heater, you could use these collectors also to provide hot water in your home as well. Another form of solar energy that we can use that is sort of a combination of the solar heat collectors and geothermal energy, which I talked about last day in my topic 2.1 discussion, are called Earth energy systems. Now, we talked about geothermal energy and how it basically uses heat deep from the core of the Earth that's being generated by radioactive decay reactions amongst elements in the Earth's core, like uranium-235. We can dig or put, I guess, collectors in lower, or I guess closer to the surface, say maybe 5-10 meters below the surface. At that point, you're not getting the heat from the Earth's core that you're getting there. You're getting essentially radiant energy from the sun that's actually heated up the Earth in that top few feet or few meters of the Earth's surface. So you're using collectors like you would on the solar heat collectors, but these collectors are now buried into the ground where they are basically picking up warmer than maybe surface temperature Earth, because the Earth holds on to the sun's energy longer. So let's say it's in the winter. It could be 20 below zero outside, but in the ground, if you go far enough down, there is radiant energy that is still there from the sun. And again, it's within reason. Maybe minus 20 might be more extreme, but let's say you've got an area where you're not getting as cold winters. Maybe your temperatures are only like maybe -5, -6. Your ground temperatures below the ground are going to be warmer, and we can bring that warmer temperature, that radiant, that lingering radiant energy from the sun that's now in the Earth, and we can convert that to thermal energy in the fluid that's running through the collectors. And you can see an example of how that would work in a home right there. But again, when you think of Earth energy systems, just think of it's a cross between heat collectors, solar heat collectors, and geothermal energy. But remember, the heat is not coming from radioactive decay in this case. The heat is coming from the radiant energy of the sun, warming up that first few feet or meters of the Earth's crust just below the surface of the ground. Then when most people think of solar energy, they think of this. They think of what are called photovoltaic cells. These are cells that convert electromagnetic radiation, and they convert it directly into electricity. This is what most people think about when they're thinking about buying, let's say, a solar panel for their home or their yard. Maybe you've got a light outside, a motion-controlled light, has a solar panel on it that helps to power it. That would be a photovoltaic cell. If you want to see how they work, here's a video on how they work, but I will explain it for you right now. Again, they're basically just taking that solar energy, that electromagnetic radiation, and they're converting it directly into electricity. And this can be done on a small scale, like on homes. There are businesses out there that actually have solar panels on their roofs. A lot of businesses in Las Vegas, again, I'll make a reference to Las Vegas, a lot of the casinos are now putting solar panels on the roofs of their casinos or their convention centers because they have so much ample sunlight coming down every day. Those rooftops are essentially just wasted space anyways. If you can put these solar panel farms on top of these massive buildings that are in, let's say, the Las Vegas Strip, they can actually generate some free electricity, so they're not having to pull so much off the power grid. And in theory, if you produce enough electricity, if you had enough photovoltaic cells in your house, potentially you could even sell back to utility companies where they're actually paying you for the energy that you're creating. And that is sort of kind of a cool thing to think about, that if you could have enough of them, that you might actually be able to make money by having them on your house, not just saving money, but actually getting money from the power companies rather than you having to pay the power companies, which is kind of cool. why don't we see photovoltaic cells, though on massive scales? Well, first of all, they only work during daylight hours. So if you have an area like Alberta where the days get very short in the winter, that is a problem. We only have like 8 hours of daylight, and if the sun doesn't really stick around that south very long, it works really well in the summer, but maybe not as well in the winter. A lot of times, these photovoltaic cells only produce DC electricity. They're only going to produce direct current. Larger electrical appliances require AC electricity, so that could be a problem. You need an inverter to convert the DC to AC. We've talked about that in the electricity unit. And in many cases, they're still not overly efficient, but they are getting better. The technology is improving. To prove that, there are some massive solar farms that are out there. One of them, one of the world's largest ones, is in Morocco. If you want to take a look at that one, it's amazing. It's incredible. There's a massive area out in the desert there that is collecting solar energy right now. And this farm uses a slightly different process, which is called concentrated solar power, or CSP, which uses mirrors that track the sun back. These mirrors actually track the sun as it moves through the sky, so they follow the sun, which gives these cells way more time to be exposed to the sun. And then all of that information, or all those mirrors, then they all target back or reflect back to a central tower that actually heats up water in the tower to about 1,000 degrees Celsius. And this causes steam to turn turbines, which generates electricity. And this again sounds very familiar. We talked about this now with geothermal energy and with nuclear energy and with tidal energy. It's all about heating something up and getting those turbines to spin, or creating that kinetic energy on the turbines. Well, this is a form of a more advanced form of photovoltaic cells. So the cells themselves in this operation in Morocco don't actually generate the electricity, but they reflect the light to a point that actually heats up water that actually creates the electricity that way. So it's a slightly different version of, it's not necessarily a photovoltaic cell, but it's a method of energy creation that the government officially doesn't want you to know or doesn't need you to know. But I think it's a cool one to think about, because it's probably going to be a very big type of energy generator in areas that have lots of sunlight. Again, we see it. I'm going to use Las Vegas as an example. There's a massive solar farm just outside of Las Vegas that uses this approach as well, just on the California border. If you're driving from Vegas to LA, just on the border there with Prim, there's a massive solar field out there, and it's using this CSP technology that we talked about. There we go. And here's some pictures that I didn't have for you before. So here's your photovoltaic cells here. Here's what the solar farms look like, and just a breakdown of how it actually works, getting your sunlight energy and converting it into electricity. And again, looking at Canada, where are some of the prime spots for harnessing solar power? As you can see on the map, the areas of the country that get the most sunlight, southern Alberta, southern Saskatchewan, southern Manitoba, are all sort of in the prime belt of solar panel activity. So that's good news for constituencies. Let's say like Manitoba, Winnipeg, Regina, Calgary, Lethbridge. These are all municipalities that could very much benefit from more solar panel use. And you're also getting some higher than normal sunlight along the Ottawa Valley there, between Ottawa, moving down toward Toronto and moving up toward Montreal. So there's some areas in there that have above average, higher than amounts of sunlight compared to the rest of the country. The last few here, 5 to 9, are less directly related to solar energy, but they are all involved. Water that melts from snowpacks is created by solar energy. So, when we have rivers that are raging, let's say from the Rocky Mountains out toward the Athabasca or the North Saskatchewan River, that's all being created because of the power of the sun to melt that ice or snow into water. So technically, this all does originate back to solar energy. Hydroelectricity, and most of you are very familiar with hydroelectricity, is basically you got water running through a dam. The kinetic energy of the water runs across turbines, which then again creates the motion, which creates the magnetic fields, which creates the electricity, blah, blah, blah. I've said it many times before already. On average, it produces about 19% of the world's electricity right now. Some regions have that number dramatically increased. For example, in Quebec, Quebec has got massive hydropower going on. About 95% of their energy needs are provided by hydroelectricity. Uh, Again, that is a lot of dams, a lot of. Is there an issue with hydroelectricity, which I'll get to here in a second? Again, dams commonly convert gravitational potential energy of water because gravity is pulling the water down. The movement of the water turns the turbines again, which are attached to generators, which produce electrical energy. You might see sort of a pattern here. Should you know the energy conversions between each of these types of energies? I would, because the government could definitely ask you a question like that, or it could be up on a unit exam or a quiz where you're going to see that information, where you're going to have to come up with they might say, well, here's your energy conversions. Which of these represents an energy conversion for, say, hydroelectricity? Or which of these shows the energy conversions for, say, photovoltaic cells? Something like that. So you should be sort of somewhat in the back of your mind familiar with what these energy transfers are, because they could come up in test or quiz assessments. What are some of the advantages of hydroelectricity? Well, it doesn't produce harmful emissions. There's no emissions at all. Water used is not polluted or removed from the ecosystem. It's just borrowed and then it's brought right back into the ecosystem. Very little waste heat is generated. It's about 80% efficient. So very efficient form of electricity generator. Or I guess it's a very efficient electricity generator. What are the disadvantages? Well, large areas of land have to be covered with water. You dam a river, that floods the river behind it. It becomes a lake, right? Look at Abraham Lake in David Thompson country. That is essentially the North Saskatchewan River that's been dammed by a dam on the North Saskatchewan. That impedes. It also impedes the movement of nutrient-rich silt carried by the flow of the river. So you're getting some of the natural process of the aquatic ecosystem are interfered with by the dam, and it also potentially stops the movement of organisms up and downstream. You may have heard of how salmon have trouble getting around these dams, and a lot of times they will create what are called salmon ladders to let these salmon go around these dams. In some cases, they'll have even helicopters picking up the salmon and then bring them on top of the other side of the dam. They've actually got one now. You can even maybe Google it on YouTube. It's like they're testing this out where it's almost like a suction device that actually sucks it's almost like a male tube, and they suck the salmon out of the water below the dam and then suck them to the other side of the dam very quickly. And apparently, it doesn't harm the salmon, but it looks like a wild ride. But if you want to Google that, type in I think it's like salmon suction device or something like that. You can find it online. I've seen videos of it, and it's they're testing it to see if it's going to work in maybe some jurisdictions to get salmon across these dams. So again, there are some issues with hydroelectricity. It's not a perfect. None of these are perfect forms of energy creation, but can we reduce as much as possible? Can we make them as sustainable as possible? Here's an example, a diagram of what a hydroelectric dam looks like from the inside. How the water turns the turbines, then creates the kinetic energy that moves the generators to create the electrical fields and then for transmission. We can also use wind power. Another one. Weather on the planet is all generated by solar activity. The sun heats up the air, and that creates different winds in different directions. So that is pretty much a 1 degree of separation from solar energy coming into the Earth's atmosphere. We're using things like massive windmills now to do this. The windmills have the turbines in them, and they have built-in generators, which then actually generate the electricity right inside of the windmills themselves. Again, solar energy is converted into thermal energy. Again, the thermal energy is then created into kinetic energy for the wind. Then the kinetic energy of the wind is converted into kinetic energy of the turbine. The turbine's kinetic energy does get converted into electrical energy by the generator. So again, 4 types of energy conversion going on there. Alberta's got some great areas for wind farms, and if you've been down to southern Alberta, down by Crow's Nest Pass, by Fort Macleod, there's some massive wind mill farms down there. If you go even further down south into Montana, some really big wind farms down in Montana as well. Palm Springs in California has a massive a windmill generator section of windmills just west of Palm Springs as well, if you're ever in that area. So you're looking for places that are windy. If you got places that are windy, you put these suckers up and away you go. Advantages, they're very versatile. They can be used on large scales for communities or small scales for individual homes, so they can be scaled up or scaled down very easily. Disadvantages, limited usage due to required conditions. So you need a place with wind. If you don't have the wind, then you can put them up and you're not going to get a lot of electrical generation. They're very inefficient. That's another major problem with them. Only about 30% compared to 80% for hydroelectric dams. And large areas of land are required for these wind farms. You need large areas to set all these windmills up on. And there have been issues with birds flying into the windmills. And there are actually companies, that have them that are now looking out for. So, for example, where these wind farms are found in, let's say, the habitats of bald eagles in the United States, they've actually got people that are actually looking out for bald eagles. And if they see bald eagles getting close to the windmills, they can actually stop them. And there's actually now software that's being developed where the software computers can scan the horizon and spot birds as they're incoming toward these wind farms, and they can actually stop the blades of the windmills to prevent potentially birds from being killed or hurt in these, while flying through these wind farms. So there is technology being developed to help with some of the problems that wind farms have kind of created for ecosystems, generally speaking. And again, how do they work? Here you go. Take a peek, and it's all about energy conversion, right? All of these are about energy conversion, converting one form of energy into another. The final conversion is going to be electricity. Let's take a look at biomass now. Biomass, if you want to take a quick peek, here's a quick peek at what biomass is about. It's fuel that's utilized. It utilizes chemical potential energy from either plant material or agricultural waste, either animals or not animals, plants that have been either harvested or plants that have been recently cut down. So it's basically essentially living, not really living material anymore. So it'd be sort of on the edge of it now. It's detritus that it's basically decomposing. But this material, whether it's fuel wood or waste wood or manure, they can all be burned in a biomass plant to heat up water. So if you take this material and put it into a biomass plant, it becomes what you burn. Rather than burning the coal, you burn biomass, which is renewable because it's, this could be waste material in a farmer's field that isn't being harvested. What about all the stuff that doesn't get harvested? Could we take that material at the end of the harvest season and actually use it to burn and create electricity? The possibility is yes. Now, again, there are some questions. If we get rid of that material, are we removing nutrients from the soil? Because that would normally be considered to be fertilizer to then replenish the nutrients that are being lost in the soil. And that is obviously an issue. But it is a renewable source of energy. But because we're burning organic material again, we're producing greenhouse gases. So there is a greenhouse gas emission problem with this one. But again, not as bad. It's not as, unit per unit as intensive at releasing CO2 and other greenhouse gases as, let's say, burning fossil fuels would be. But again, not ideal, but it's another way to think outside the box. That's what all this is about, is can we think outside the box to generate new forms of ways of creating electricity. Another example, or another thing we can use biomass for, rather than burning it, is we can actually convert it into what's called biofuel. We can use it to create things like ethanol, things like biodiesel, like biogas. These are all things that are basically, they're like fossil fuels, they're like petroleum. They're not quite as efficient at generating power, but again, it's all coming from renewable resources. So you may have heard of ethanol-infused gasoline. You have ethanol, 10% or 15% ethanol-infused gasoline. That's not necessarily a bad thing. It's going to be less greenhouse gas emissions, but there is going to be a little bit of loss of power when you're driving the vehicle. So if you don't mind losing a little bit of power for the sake of being a little bit greener to the planet, it's certainly a thing to think about. What are some of the advantages of biofuels? They are considered to be renewable, which is good because you're getting them from plant material, organic material that's not in a fossil form. They reduce our dependency on oil and slightly reduce greenhouse gas emissions, as I just mentioned. What are the disadvantages of them? Well, again, they are low energy molecules compared to other fuels, making them less efficient. I talked about that already. Higher concentrations of ethanol are toxic to organisms, so you have to watch out for that. And the growth of fuel crops. If we're going to start growing crops specifically to make biofuels, that leaves less land for us to actually grow food, right? So, I mean, if a farmer finds it's more profitable to grow crops to make fuel, he will or she will, right? But what about people who want to have food and have cheaper food prices? This is going to be an issue, especially as we get more and more people living on the planet. So that's something else to consider. Finally, the last one on the list, hydrofuel cells. Now, hydrofuel cells, I'll give you a quick little video link right here if you want to see what they're all about. But they are similar to batteries, electrical chemical cells like batteries that use chemical potential energy. However, unlike these batteries that use sometimes some toxic substances, some heavy metals in them, this type of fuel cell uses two elements, hydrogen and oxygen. So it's using two very common, easy to find elements that are in the atmosphere and all around us. So again, considered to be more of a renewable resource, because when we take these two elements together, the only byproduct other than the production of energy by the cell, they're going to produce water. They produce water as a byproduct, as an emission. Like, well, water, that's about as healthy as you can get. Although, technically speaking, water is a greenhouse gas. So we do have to address that elephant in the room, that water is a greenhouse gas, but water is part of the water cycle, and it's sort of naturally all around us. So we're just recycling hydrogen and oxygen to produce some water. That water will then cycle through biogeochemical cycles like it normally does, and then will find its way into watersheds or whatever. So maybe not as bad of a greenhouse gas to release as opposed to CO2 or methane or nitrous oxides or whatever. Currently, this renewable energy source is limited because of the high cost of the catalysts that are involved in creating the reaction and the relatively large size of the cells required. So the idea is that this would eventually maybe go into would power vehicles at some point in the future. Research is ongoing to make this very energy efficient cell more common in the future. It is a very efficient form of energy creation, as you might have seen if you watched that video. In the end, though, which of all of the energy sources that I've talked about in this unit is the most efficient? If you want to know which one is the absolute most efficient of the bunch, watch this video. They will give you the run through of all the different types of energy out there and their general efficiencies compared to one another, and then you can see for yourself which one is going to be the most efficient that you might want to decide to champion at some point in the future as you go out and become some famous scientist or some famous entrepreneur out there trying to make their mark by making some newer and more efficient forms of energy use. That's it. Course is done. Congratulations, everybody. I got a few questions for you to finish up the course before we start review. Here it is. You've got questions 2 to 6 on page 555. You got questions 4, 5, 6, 7, and 11 on pages 556 to 557. Whew. That's it. Thanks a lot for tuning in, everybody. I hope you've enjoyed my look and my take on Science 30. I know it's not perfect, but let's be honest, who in life is. Thank you for taking the course. Thanks for tuning in to whichever videos you watch. Hopefully they were helpful for you. Hope to see you real soon. Maybe for review, maybe for class. Maybe I'll see you just walking down the street here in Warrenville. But regardless of where I see you, thanks for tuning in. And all the best, and hope to see you in the future. Take care.